This is Chapter 2, Part 3, Firewall Fundamentals. First, we'll discuss static and dynamic packet filters. Static filtering is constant and unchanging. The connection values, the address, port, and protocol are known in advance. Connections must use well-defined ports and protocols. Sessions are not observed start to finish between endpoints. Dynamic filtering adapts to live traffic by learning which ports are needed for a session and blocks all others. The firewall monitors inbound connection requests. Legitimate requests are tracked from start to finish. When the session ends, the firewall closes the ports. Network address translation. It translates internal addresses to external addresses. It creates one-to-many mappings to extend IP address class availability and share a common internet connection among several hidden hosts. NAT allows you to bypass individual IP assignments for an ISP. It can create choke points through which all traffic must pass. It reduces the cost by using a single internet IP address among several internet computers, and it extends the full IP address class ranges to smaller separate network segments. NAT conceals internal machines from the external world. It keeps private systems hidden from external access or view, and lets multiple internal connections appear to originate from one external system. Application Gateway Overview. An application proxy or application gateway is like a packet filter but focuses more deeply on application protocol behaviors. It acts as a middleman between the client and the server. Firewall and proxy combination achieves the defense in depth strategy. Application Gateway is a packet filter. Static packet filters only inspect packet headers and segments. The application proxy can fully inspect traffic up to the application payload. It operates at any layer of the TCP/IP reference model. The application gateway serves as a middleman. All application-specific communications are handled between the client and server. It maintains separate connections between the client and server or firewalling. It's not transparent. The client is configured for proxy use and therefore is aware of it. Application gateway is used in defense in depth. Firewall and proxy combination achieves the defense in depth strategy. The application proxies filter on the content in the application layer payload. The network firewalls filter on lower level protocol properties. A network circuit proxy. A circuit proxy or circuit level firewall filters on connection-oriented startup. It observes the initial setup of a circuit, session, or state. Once connected, a circuit is no longer filtered traffic. Circuit proxy filtering rules. Circuit proxy filtering rules are similar to those in static packet filtering. Static values determine which circuits and connections are allowed. Filters can be set to default deny or default allow. They're generally faster than application layer firewalls due to the fewer packet evaluations. They're useful for connection-oriented protocols that perform TCP/IP handshakes. Software firewalls are installed on host computers, such as built-in Windows firewall or the Linux packet filter. It competes for shared resources on the host computer. Static placement filters only connections made from or to the host, and protect only one system on the network unless forwarding IP traffic. Hardware firewalls are installed on dedicated devices. Firewall appliances and dedicated routers with firewall services. That's what these hardware firewalls are. Strategic placement throughout the network filters end-to-end connections, and a standalone unit can protect multiple systems on the network. They can be optimized for network performance. Combination is you achieve defense in depth by combining hardware and software firewalls. Layered protection at the network and host levels by separate firewalls, especially practical for mobile employees that telecommute to work. Host-based firewalls protect only the local computer. They filter traffic passing through the local system only. They can filter traffic for other systems such as Windows Internet connection sharing. Host-based personal software firewalls come into this category. They're not optimized for firewall filtering. Network-based firewalls. These span an entire network. They filter all traffic passing in and out of the network or network segment. They can filter between other networks and systems. They can be commercial or corporate firewalls, optimized for network-wide firewall filtering. They can incorporate enterprise-grade network services such as VPN, enterprise-class encryption protocols, and enterprise-class security services. Single-homed firewalls have only one network interface. There's no physical isolation between the internal and external networks. The ideal separation between the host and the network, and they cannot provide sentry services between network segments. Multi-home firewalls means more than one network interface. Dual or triple homed. Filter local traffic on an internal network interface. Filter remote traffic on an external network interface. Filter traffic between the internal and external interfaces. Create electronic isolations among segments, subnets, and networks, and ideal network separation with sentry services between networks. In summary, we talked about the types, features, and functions of firewalls, essential TCP/IP characteristics, software-based and hardware-based firewall solutions, filtering and port control strategies and functions, and home firewalls and their placement.